let's take a simple look at carbon dioxide. Is it good or bad for Earth? An increase in carbon dioxide, CO2, will cause the Earth to warm. And the answer to that is yes, but how much? And when you hear about the problems of carbon dioxide, it's a good idea to ask yourself, who speaks for what the carbon dioxide level should be? And some climate models say that carbon dioxide will increase, the content in the atmosphere will increase by the year 2100, and that'll cause a temperature rise of a degree, depending on what models you look at and who you listen to. Others will say that in the tropics you might get actually a 2 to 4 degree increase in the temperature, and in the mid-latitudes. And at higher latitudes you'll get 4 to 8 degrees increase in the temperature. I think it's important to point out how the word carbon is used. And you'll frequently hear people talk about carbon, pollution, and carbon footprint. But what they're really talking about is not the element carbon, but the molecule CO2. And this seems to be embedded in the way news reports frequently go. And to me, that's like saying that water, which is H2O, that's like calling water hydrogen. When in fact, it's H2O, and it's not carbon, it's carbon dioxide. So let's take a look at some levels of carbon dioxide. We come over here. The current level of CO2 in the atmosphere is roughly 400 parts per million. And if you want to convert that over to percent, it's easy. You have 400 over 1 million. You multiply by 100% to convert a ratio to percent. And so that gives you 0.04%. So you can talk about the current level as being 400 parts per million or 0.04%. When you breathe out, the concentration of CO2 in your breath is roughly 40,000 parts per million or 4%. Plants need something greater than about 150 parts per million to grow well, or 0.015%. And to show you that as an example, this is a scaled reproduction of some tests that were done with trees growing in different levels of carbon dioxide. Here is the current level of carbon dioxide, the tree growing in the atmosphere. And then by increasing the atmosphere around the tree by 150 parts per million, you can see the tree in the same amount of time grew a little taller. And then increasing it another 150 parts per million, you can see this tree, instead of being this tall, would be this tall. And another 150 parts per million, it would be considerably taller. So plants like carbon dioxide. The carbon dioxide level on Navy subs is supposedly kept below 8,000 parts per million, or 0.8%. The International Space Station is less than 5,000 parts per million, or about 0.05%. The Apollo 13 mission to the moon that had a problem, the CO2 alarm, I've seen people report that it fired off at 300 parts per million when they were having a problem, or 0.3%. And it actually reached about 20,000 parts per million, or 2%, before they fixed the problem. Inside buildings, you have roughly a concentration of CO2 of about 1,000 parts per million, or 0.1%. And as I showed you with that little tree model, things grow better when the CO2 level is higher. And they actually add CO2 to greenhouses by burning, I think it's either butane or propane. And they like to have about 1,200 parts per million, or 0.12%. And you're going to have trouble staying alive if it gets up to about 10%. So that's an example of a number of different things with different levels for the carbon dioxide. And the really interesting thing is how plants grow better when the carbon dioxide level increases. Now, there are a number of factors that affect the carbon dioxide level. And there's a number of factors that influence the temperature on the Earth's climate. And one of those is the sun, which plays a very important role. And then the Earth's orbit and the tilt of the Earth's orbit. And then there are a number of, they're like external factors that influence the Earth's temperature. And then there are some internal ones, one of them being carbon dioxide, another being water, other gases, ocean currents, and volcanic activity. But what we want to focus in on is CO2. And so the molecule of CO2 looks like this: oxygen, carbon, oxygen. And you can stretch the CO2 molecule, and that will cause a particular transition. And that amounts to a photon being emitted or absorbed with a wavelength of about 4.2 micrometers. So it's in the IR. Another change that the carbon can so this is a stretch. Another change that can occur is a bend. And in that case, the energy involved in the transition of going from here to here is, or the wavelength involved for the photon is 15 micrometers. So the stretch, the wavelength of the photon involved is 4.2 micrometers, and for the bend, it's 15 micrometers. And now let's get an idea of what photons are being emitted by the Earth that interact with the CO2 so that the CO2, in a sense, keeps heat around the Earth. So let's say here's the sun, and over here's the Earth. And we're receiving about 1,360 watts per square meter from the sun. 1,360 watts of power for a surface of 1 square meter located orthogonal to the sun. That warms the Earth, and that warms the Earth to temperature of about, well, we have the visible light coming in, and then to have equilibrium, we have IR leaving the Earth's surface. The sun's visible light warms the Earth's surface. The warmed Earth's surface emits IR, and the amount of energy emitted by the infrared balances the energy from the sun. And so that causes the Earth to have a temperature of about 288 degrees, 288 Kelvin. And if you take a look at Wien's displacement law, and what that tells you is if you look at the black body curve for some temperature, this is temperature and power energy over here, the maximum wavelength the curves are for a particular temperature. This is a wavelength axis. There's a lambda max. That's a result of Wien's displacement law. And the way that looks is very simple. You would say that the wavelength max emitted by the Earth, so the temperature here we'll say is 288 Kelvin. And so the expression for this is a constant divided by the temperature, and that constant is 2.898 meters Kelvin. See, I want to write it as meters Kelvin, so that will be times 10 to the minus 3 meters Kelvin. That's the constant, the Wien displacement law constant, divided by the temperature of 298. And we want to convert that to microns, so we have 1 meter over 10 to the 6th micrometers. And if we work that out, lambda max works out to be 10 micrometers. And so the point is that this emission from the Earth, in the balancing of the energy from the sun and what's emitted in IR, this is in the IR, is close to these guys. So a lot of the energy emitted by the Earth's surface can then be absorbed by the carbon. And so what that means is, if you say that's the outer part of the atmosphere, and down below here is the green Earth, so we're having emissions of IR, and what will happen is it will be absorbed by the CO2 in the atmosphere, and then it will be re-emitted. Some of it will come back down, some of it will go back up. But the point is that the atmosphere will absorb that energy, and that can cause an increase in the temperature of the atmosphere. And so that's how carbon dioxide can increase the temperature of the Earth. Now, this warming of the Earth, is it catastrophic? C-A-S-T, catastrophic. I hope that's right. And is it catastrophic? Well, depends on who you talk to, but I think it is probably not catastrophic. And there's a quote over here. A lot of people who are saying how bad things can be. If you focus in now on that quote, this was given by President Eisenhower on his farewell address to the nation, and he says, "Today the solitary inventor tinkering in a shop has been overshadowed by task forces of scientists in laboratories and testing fields. In the same fashion, the free university, historically the fountainhead of free ideas and scientific discovery, has experienced a revolution in the conduct of research, partly because of the huge cost involved. A government contract becomes virtually a substitute for intellectual curiosity. For every old blackboard, there are now hundreds of new electronic computers. The prospect of domination of the nation's scholars by federal employment, project allocations, and power of money is ever present and is gravely to be regarded. Yet, in holding scientific research and discovery in respect, as we should, we must also be alert to the equal and opposite danger that public policy could itself be the captive of a scientific technology elite." And that may be, in fact, what is happening now, that a lot of people are making claims about carbon dioxide, how dangerous it is to the earth, the increases, so we shouldn't be using hydrocarbons, which are a source for extra carbon dioxide in the atmosphere. But all the work which are predicting these catastrophes are based on models. The models come mostly from the universities that receive government money. And so there is a big question as to really what the motivation is for a lot of the claims that are made. But to answer the question as to whether or not there is actually proof of global warming, climate change due to CO2, I don't think there really is, and the closest proof that I've ever seen is this one over here. This picture appears in a number of places, and one of the places I saw it is indicated here. So if we come back over to here, I think the important part is that we really need to take a better look. And the issue so much isn't climate change. As it seems to be more a problem of science change. And what I'm suggesting with that is we frequently hear that climate change from carbon dioxide, from the burning of fossil fuels, it's settled science. And that's where it seems like science is changing. Because there's a very good dictum, and what it says is that what is certain is not science. What is certain is not science. And what is science is not certain. And so it may be more of a problem of having people say that it is settled science and there is no such thing as settled science. Everybody knows that if you have a hammer and you drop it, it's going to fall to the floor. That's a fact. You can describe that using Newton's law. You can describe it a little better, especially if you're standing on a neutron star, by using general relativity. And somebody else will probably come up with some other way of explaining the falling of a hammer, the gravitational field. So there's no such thing as settled science. And that is the thought that I want to leave you with. No such thing as settled science. So what is science is not certain, and what is certain is not science.